Hey guys, welcome to Algos Explained. My name is David Kim, and today we're going to be I'm bringing you a question from Code Wars, an algorithm question like all the other ones in this playlist. If you're here, this one is a level 6 question. We're going to be doing this in JavaScript, and so you know the drill. Let's go ahead and get started. Given two arrays, or this one's called which are in. Given two arrays of strings A1 and A2, return a sorted array R in a lexicographical order of the strings of A1 which are substrings of strings of A2. Okay, that's kind of confusing, especially if you don't know what that means right off the bat. But let's continue. I'll explain all this later. Example one: A1 has three in it: ARP, live, and strong. A2: lively, alive, harp, sharp, Armstrong. And so let's go ahead. It returns ARP, live, and strong. Example 2 returns tarp, mice, and bull. Or no, it doesn't return that. That's A1. A2, lively, alive, harp, sharp, Armstrong, and it returns nothing. So let's look at these notes. Arrays are written in general notation. See your test cases for examples in your language. Okay. In Bash, A1 and A2 are strings. The return is a string where words are separated by commas. Beware R must be without duplicates. And I was kind of thinking about that because we see how we have A1 live, live. This one has lively, and this one has alive. And so, despite having this element of A1 in two words of A2, we only outputted one out there. And so, yes, that follows with this beware R must be without duplicates. So, let's talk about this lexicographical. That just means alphabetical. I didn't know off the top of my head what that meant, so I googled it, and Wikipedia was just telling me that's another way to say alphabetical order. And people will do that. They'll give you like these little things to throw you off. But if you don't know what that means, just go ahead and ask them. Whoever you're talking to, whoever's giving you this question. And I think there's no shame in that. It's a lot better than trying to pretend that you know and just getting it wrong later. That not asking questions about what you don't know, I think that's pretty stupid. Not knowing is okay. Not asking, that's something different. But anyways, let's go ahead and kind of think about how we're going to be doing this. And so we know that we're going to be outputting an array. And what I like to always do is I like to kind of go ahead and get the output started. And so I'm just going to call this in array, and we're going to make that into an empty array, and we're going to return in array. And so now what are we going to be doing with this? We're going to be putting inside here words of A1 that happen to be substrings of words in A2. And so let's see if that was easy to decipher from reading this. Given two array of strings A1 and A2, so we know that, okay, we're giving two strings, and we know that by the examples also. Return a sorted array in lexicographical order, so alphabetical order, of the strings of A1, which are substrings of strings of A2. So kind of a tongue twister, especially if you let lexicographical throw you off, but I feel like this is kind of fairly kind of on the clearer side. It could have been more confusing, but it says return a sorted array of strings of A1. So we want this return to only contain words from A1, which are substrings of strings of A2. So if any of these guys were substrings of these strings in A2, then we want those. We don't want words from A2. We don't want that. And so we know that, okay, we're going to be taking words from A1 and we're going to be comparing them to words in A2, and we're going to be creating an array. And so what does that mean? What did I just say right now? Let me rephrase that. We're going to be taking words from A1, which means we're going to have to be looking at every single word in A1, and we're going to have to compare it to every single word in A2. That sounds like a nested for loop, because we're going to have to take every single word from A1, and we have to compare it to every single word from A2. And so let's go ahead and kind of set that up, see how that would look like. We know that we don't want to repeat words, and so, well, at this point, if you kind of agree with me that we need a nested for loop, now which loop goes on the outside and which is the outer loop and which is the inner loop. Kind of what array are we looking at on the outer scope, and kind of what array are we going to be looking at from the inner for loop in that area. And so I actually, when I was first doing this question, I flipped it. I flipped it wrong, and I realized kind of why I did it wrong. And so let me do it the right way for you, and then I'll explain to you kind of when I flipped it, how I realized that was totally wrong. And so let's go ahead and create this loop. We're gonna let, we're gonna let I equal 0, and I is less than array 1 dot length I plus plus. And our next for loop, we're gonna have it with j. Array 2 dot length j plus plus. Okay, excuse me. And so what we're going to be doing here is, given our for loops, we're going to be looking at every single word in array 1, and for every single word, so for every time we're on one element of A1, we're going to be boom, 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 boom. We're going to be flipping through A2. And so, and every time and when we get to the next one, we're going to be flipping through all of A2 again. And when we get to the third one of A1, because that's the outer one, we're going to be flipping through all of A2 again. And I believe that's important because maybe ARP and strong, maybe they are both the substring of one of the words in A2. Maybe it was called ARP strong or live strong. We've heard that term before. And maybe that was a word here. We don't want to exclude any words from A2 just because one of A1 was already a substring of that. And so there you have it for that. So now let's look at the logic. How are we going to do this? Well, we know that we're going to have to check if this element that we're looking at from A1, is that a substring of A2? And kind of, I believe one of the easiest ways to do that is using the index of method and checking if that number is not a -1. And that is simply because when you do an index of, and you can do index of strings, and you don't have to do, some people think that you have to just be comparing a single letter. You could actually compare a string against a string and do index of, and if that string that you're checking against is in the index of that, it'll give you the index of the first element where it starts. So that's what we're going to be using exactly. We're going to do index of an array 1 of I. And don't get these wrong over here, because array 2 of j, we're using that, and array 1 of I, we're using up here. You don't want to say array 2 of I. It will work sometimes because index numbers, especially if it's in completely equal array, it will definitely work. But say array 2 doesn't have kind of the index of whatever we're at, it's going to be trying to call index of on an undefined, and so that's probably going to throw you some errors right there. And so we're going to check, okay, is the word we're looking at, so if we take that first example, ARP, is ARP within the index of kind of one of these guys, whatever we're at, whatever j represents. And if it is, then we're going to get a number. It could be 0, it could be something else, so we don't want to just see if it's true or not. We want to see if it's not -1. And so if it is, then we're going to, if it's not -1, that means we got a number, whether it's 0 or whatever that index is. And so in array is going to be, it's going to get something, array 1 of whatever we were looking at right there. And I'm going to add a break here because there's no need to keep on looking at it. If array 1, if array 1, let's say if we had an example like ARP and 2 of these guys had ARP in it, or just like live, this is a perfect example. We're at live, say array 1 of I is at the live. And we go to looking at this, lively, and we check, okay, it is an index, so we're going to push that in there. We don't want to continue looking at that next one because guess what? It does have it, and if we didn't break here, it's going to add it in again because we're going to be looping through this for loop until the A2 is finished. And in that case, if we were at live, it is going to do it twice. And so we're going to be breaking as soon as we push an element of array 1 into array, or as soon as we push an element of array 1 inside our inner array because it was a substring of something in A2, we're going to break it and we're going to move to that next one in array 1. That's what that break is there for. And so we do that, we return in array, and that should work. Oh, great, we have a problem here, and let's go ahead and see where we messed up. Let's see. So, okay, so in array, okay. We want to look at this. Expected arp live strong, instead got live strong arp. And so it looks like this is definitely the right one, but it's not in lexicographical order. And so we want to make that into that. And so array 1 dot sort. Oops. And that will solve that one. We were looking at array 1 in unsorted order, and so therefore when we were outputting it, we were pretty much inserting into array as an unsorted array. We could either sort the array here or we could sort the array here. Doesn't matter. I decided to do that up here. And so going back to when I flipped the array, kind of the array 2 as the outer loop and array 1 as the inner loop, maybe I covered it already, sort of, but if I were to have been spinning inside quickly with the array 1, having array 2 outside, that would mean that every time, I could still do the comparison here, but that means that every time I was on one word of these, I would be checking, okay, this one, or this one. And I didn't want to do that because there would be no kind of, it would be, I don't know, I felt like it was harder, kind of, this break, the whole purpose of why we did this break. I felt like moving on to the next one of A1, that was a lot easier when the array 1 loop was on the outside. And so, say we were on ARP and we got into it by sharp. And so maybe, yeah, we'll move on to kind of, or actually that wouldn't matter. We would be looking at lively from the outside and we would be comparing all of these guys. And so we would catch, okay, live, on lively, we would add that in there. And when we were at alive, we would have no real way to know, okay, we should skip this one or not. And we would, if A2 was on the outer loop, we would be looking at that, boom, 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 catching all three of these guys. Live would go inside in array. We move on to alive. And we would have to check all three again, and we wouldn't really know. I mean, we could kind of prune this at the very end, but why do that when we could just simply flip the array 1 to be on the outside and array 2 on the inside? But of course, like with all algorithms, there are many different ways to do this. You could, if you want to use something like filter, this might be a good time to use it. I didn't because kind of the whole nested thing is kind of more confusing when you try to use filters. I feel like it was clear to explain it this way. But filter, is outputting an array for you. So, hey, this might be the best time to use something like that. Yeah, so if you enjoyed this question, be sure to like, comment, and subscribe. I'm going to have my code, what I've written here, inside a repo. That's going to be in the description. If you want to add yours to it, feel free to do so. But other than that, I'll catch you in the next one.